Hi, in this video we are going to talk about a new programming technique called prefix sum. Let's understand this with an example. We are given a fixed array. The array elements do not change. We do not increase the size, do not change any element. It's a fixed array. And on the same array, we have multiple queries of the type getSum. This getSum query takes two indexes, left and right, and we need to find the sum of elements between these two indexes, including these two indexes. So if 0 and 2 are passed, then the sum is 2 plus 8 plus 3, which is 13. If 1 and 3 are passed, then sum is 8 plus 3 plus 9, which is 11 and 9, 20. If 2 and 6 are passed, then sum is sum of these elements, right, which is 27. How do you efficiently perform these queries on a fixed array? You may consider a situation where you have thousands of queries on the same array. How do you perform these thousands of queries? A simple solution to solve this problem is to run a loop for every query. You can simply do this, like for int I equals to L, I smaller than equal to R, I plus plus, and then you say to initialize a variable sum equals to 0, then you do sum equal to sum plus array I. You finally return this sum. How much is the time complexity for this? The worst case time complexity for every query can become big O of n, because I might give you all the left and right values 0 and n minus 1. So worst case time complexity is going to be big O of n. Can you solve this problem in big O of 1 time by doing some pre-processing over the array? So when I say big O of 1 time, you need to answer all the queries, all the thousands of queries in big O of 1 time. However, you can take big O of n time to pre-process the array. You may pause this video now and try to come up with a solution yourself that takes big O of 1 time to answer every query. So the idea to solve this problem in big O of 1 time, to answer these queries in big O of 1 time, is to compute the prefix sum array. Let's understand what is a prefix sum array. Let's try to write a prefix sum array for this array. So prefix sum array is an array which has sum of elements from 0 to I at index I. So for this array, this first element is going to be 2, next element is going to be 2 plus 8, 10, next element is going to be 10 plus 3, 13, next element is going to be 22, then 28, then 28 plus 5, 33, 33 plus 4, 37. So that's our prefix sum array. So how much time it takes to build this prefix sum array? It's going to take big O of n time. I'll initialize prefix sum of 0 equals to array 0. Let's write this code also, let's run this code. How do I build this prefix sum array? I make an array prefix sum of same size as my input array. Then I initialize prefix sum of 0 as array 0. Then I run a loop for int I equals to 1 from the first index, I smaller than n, I plus plus. And I think you can guess rest of the statements. I'll do prefix sum of I equals to prefix sum of I minus 1 plus array I. Right, so I filled 2 explicitly at location 0. Then I do from first location, take the previous value of prefix sum, add the current element. Take the previous value of prefix sum, add the current element. So I get 13. So this is how I get prefix sum array in big O of n time. Once I have built the prefix sum array, how do I answer these queries in big O of n time, big O of 1 time? How do I answer every query in big O of 1 time? Let's understand the idea. So I think you must have guessed the idea. The idea is simple. I can find the answer of a query by subtracting prefix sum L minus 1 from prefix sum R. For example, this. Let me write down what I just said. Prefix sum R minus prefix sum of L minus 1. There is one thing that has to be handled explicitly. What if L is 0? that has to be handled explicitly. But let's now talk about the cases when L is not 0. So let's not take this example for now. Let's take this example. So what are we doing? We are taking the prefix sum 3, which is 0, 1, 2, 3, 22. We are subtracting prefix sum of 0 from it. So 22 minus 2, 10. So we got the answer 20. So the idea is simple. We have the sum of elements in prefix sum I, sum of elements from 0 to I. So to get the sum of a range, I subtract prefix sum of elements before this range from the sum of prefix elements till the prefix sum R. How do I handle 0 case? Let's write this function. I have a prefix sum array to this function. I have 2 indexes int L R. So this is fine if L is not 0. What do I do in the else part? I think you must have guessed. I'll simply return prefix sum of R. That's how I answer every query in Big O of one time. I simply, to find the sum in this range, L2R 1, 2, 3, I took the sum till this value and I subtracted the sum till this value. That's how I get the sum of this range. So for, say, I want to get the sum of range from this to this, what I'll do, I have the sum of elements till this point in prefix sum of R. I'll subtract the sum of elements till prefix sum of L minus 1. That's how I get the sum. That's the idea to answer the query in Big O of one time. Let us now talk about next problem, which is based on prefix sum technique. So the problem is, given an array, we need to find if this has an equilibrium point. What do we mean by equilibrium point? A point such that sum of elements before it is equal to sum of elements after it. So if you take a look at this point, sum of elements before this point is 3 plus 4, 7, 7 plus 8, 15, 15 minus 9, 6, and sum of elements after it is also 6. So there is an equilibrium point. That is why our answer is yes. If we take a look at this example, there is no element such that sum of elements before it and sum of elements after it is same. If there is a corner element, can we consider it as an equilibrium point? Yes. We consider the sum of elements on left of the leftmost element as 0. So this is an equilibrium point because sum of elements on right side is 0 and there is nothing on the left, so sum of elements on the left side is also 0, so we consider it as an equilibrium point. Similarly, if I give you an example 2 minus 2, 4, this also has an equilibrium point 4 because sum of elements on left is 0 and there is nothing on right. So we need to find if array has a point such that elements before it have the same sum as elements after it. How do you solve this problem efficiently? A naive solution, simply run a loop for int I equals to 0 and inside the loop check if the elements before it have the same sum as the elements after it. So I compute the left sum as sum of elements before I, right? For int j equals to 0, j is smaller than I, j plus plus. That's how I find the left sum, plus equal to array j. Similarly, I compute the right sum for int k equals to 0, k equals to I plus 1, k is smaller than n, k plus plus, and I say I initialize one more variable, right sum here, and I say right sum is equal to plus equal to array k, and then I say if left sum is equal to right sum, then this point I is an equilibrium point. What is the time complexity of this approach? How much time it's going to take? It's big O of n square, right? Because we are running a loop inside this loop, so it's big O of n square solution. Can you think of a solution which is big O of n? So that's big O of n square solution. If the left sum equal to become right sum for any point, we return true, and if we come out of the loop, we return false, that we did not find any equilibrium point. right? So that's big O of n square. Can you think of a big O of n solution which is based on prefix sum technique, obviously? So you may pause this video now and think of a big O of n solution. So a simple solution which is big O of n solution is to compute the prefix sum, compute the suffix sum similar to prefix sum. Suffix sum I has sum of elements from n minus 1 to this index I, right? For every index, check if prefix sum of I minus 1 is equal to suffix sum of I plus 1. If that is true, then you return true for that index. The problem with the solution is it requires 2 auxiliary arrays and 3 traversals of my input array. I'll first compute the prefix sum, then I'll compute the suffix sum, then for every index I'll check if prefix sum is equal to suffix sum. Although I can combine prefix sum, suffix sum computations in the same array, but still requires big O of n extra space. Can you solve this problem in big O of n time and big O of 1 extra space? You may pause this video now and try to come up with a solution which is big O of n time and big O of 1 auxiliary space. So we do not compute prefix sum array this time, right? We use the prefix sum technique, but we do not compute explicit array because we need to solve this problem in big O of 1 extra space. How do we solve it? The idea is this: we first compute the total sum of the array, then we traverse from left to right. So I can get the left sum in a single variable when I'm traversing from the left to right. And how do I get the right sum? I subtract this left sum from the total sum. That's how I get the right sum. So let's try writing the code. I'll write a Boolean function is equilibrium point, which takes an array as an argument, size of an array, and then I'll first compute the total sum of the array. So this is how I get the total sum. Now to check if every point is an equilibrium point or not, I'll initialize a left sum variable and I'll keep updating it from left to right. What I'll do is I'll check if left sum is equal to sum minus array I. Why am I doing sum minus array I? Because when you say right sum should not be including array I, right? And left sum you already have in a variable. And leftmost element can also be an equilibrium point. So we first check for this thing that right sum is 0 or not. Right sum means sum excluding array I. If that is 0, then if that is equal to left sum, then we return true. Otherwise, we keep iterating to the next element. We update the left sum is equal to plus equal to array I. We add current element because this is not equilibrium point. The next point might be equilibrium point. For next point, it should be part of left sum. We also reduce sum. We remove the current element from the overall sum because this element is not going to be part of right sum. And if I do not find any equilibrium point, then I simply return false after writing this loop. Right, so that's the whole logic. We first computed total sum of the array. Then we initialized left sum as 0. Then we ran a loop. We checked every point if it is an equilibrium point or not. How did we check? We compared left sum with total sum minus array I. If they are same, then we return true. Otherwise, we update left sum and we update sum so that we have proper right sum for the next element. So this is big O of n solution. It requires big O of 1 extra space, right? And finds if there is an equilibrium point or not.